Okay, so the recording has been started. Welcoming you all again in the class of financial analytics. Sharing my screen with all of you, showing you the data in which we were working last time around. Everyone should be able to see this kind of data on their screen. Let me use the magnifier as well so that you get it in a better way. Okay. So just give you a very brief idea about it in a minute so that you will be able to again come back into the lecture. We had three types of investors. We had found their monthly return from the data which we had. Now their portfolios were different. The portfolios were allocated based on their risk-taking capacity. The ones who were aggressive in nature, they were allocated more amount of equity. The ones who were balanced in nature, they were allocated less amount of equity. And the ones who were conservative were allocated too much amount of, safe assets and very less amount of equity. Now, based on that, we had found the average return yearly. And I told you that how you cannot find the simple mean over there. You will have to find the geometric mean. And I had given you the formula to find the geometric mean from the monthly return. Now, the logic behind finding the geometric mean was that these two returns, that is 0.14 and 0.17, if you understand, every such returns are not comparables. Why they are not comparables? Because the amount of portfolio would be different in every month. So there has to be a multiplication of all of these returns. In a compounding manner, we should find this. So what did we do? We just added 1 into those monthly return. Now, if you would have taken a simple average, you would have found the near about answers, not this one exactly, but that would be a little bit misinterpretation of the data, because you cannot take all these returns into a similar umbrella, into a blanket manner. All are not comparables, because the portfolio amount in every month would be different, and based on that, these returns will be calculated. So that's why you should multiply this and compounding. So what did we do? We added 1 in every such return, and then we had just used the product, that was nothing but the multiplication of all the returns including 1, and we had reduced 1 from that. So we found 8.8 percentage as a return for year number 1 for the portfolio number 1, and accordingly for all the portfolios we had found the yearly return. Is everyone with me till now? If you are there with me till now, then I can move ahead. Give me a confirmation, positive or negative, everyone. All of you. Good. Only 2 confirmations. So rest are doing it, or what? I'm not aware about it. Khyati has given as well. Jinkal too. Good. Everyone else, I hope you must have calculated the yearly return. There was absolutely no rocket science in that. आपको कुछ नहीं करना था, आपको सिर्फ आपका जो मंथली रिटर्न है उसमें आपने एड 1 किया है, उसको प्रोडक्ट करके. व्हाट इज द मीनिंग ऑफ प्रोडक्ट? Product means the multiplication of all this, and then you had reduced -1, so you get the geometric mean of all these returns. Now once that is done, now we want to check that how these returns are distributed, whether we are able to see the normal distribution of the data or not. Now based on that, some of the students would be like, sir, what is the normal distribution of the data? Yes, in some of the subjects like research methodology or in statistics, you must have heard about it. But in case if you haven't, I'm assuming that you are not having any knowledge of it. Let's start it right from the scratch. Now, what do we understand by the normal distribution of the data? Now try to understand this. Now what happens is that when you distribute the frequency of the data, no, then in if I give you the example of your class only, the majority of the people will be nearby the average marks, right? That's how it would be. The majority of the people will be near about the average marks. Say there is a marks of financial analytics, and here we have the average, and the marks of financial analytics out of 100 is coming at, say, average is coming at 60. So majority of the students will be falling nearby the average. Now how this average looks like, how these averages and the standard deviations are distributed. Now before I go to that, let's first try to find the histogram of this frequencies. What I'm doing is, we are going to the monthly return of every individual investors for their portfolio. I'm selecting it entirely. For the first one I have selected it, everyone do it, and based on that I will explain you what you will be doing. Once the monthly returns are selected, is everyone there with me? I'm selecting for the first one as of now. Then I need to go to the insert tab, and in insert tab everyone should be able to see this histogram. Is histogram there in everyone's computer? Just let me know. If not, then just please give me a confirmation. I think for all the versions above 2016 or 19, the histogram must be present. If it is not, then we have a second way as well. Please let me know. Histogram, no, you have a second way as well. You may go to the right arrow of any chart, and from there you can go to the more charts like this. And once you will open the more charts, no, then all the types of charts will be visible to you over there in that tab. See, all such sort of charts are visible to you now. So you are going to the insert tab, and in that insert I'm going to the histogram and selecting the first one. Now you see it has already given the frequency distribution, and if you can see, the range, these are the two bars where majority of the returns are falling. Now what this chart is telling us, that in this particular range of returns, how many returns are falling. So the interpretation of this bar is that between 0.23 percentage to 1.43 percentage, 41 number of returns are falling. So whatever the returns we have taken here, 41 items are there which are falling between these two ranges, that is 0.23 percentage to 1.43 percentage. Now how did I identify 41 entries? Because from here I can see that around 40, 41 something. Now on the similar manner, if someone can give me an interpretation of this bar, please unmute yourself and let me know. This bar, what is the interpretation of this? Anyone? Anyone would like?
40, 42 value is between the 0.23 percentage and 1.43 percentage.
Okay, that I have said. The next one, this one. You're perfectly right.
Between 1.43% and 2.63%, there are about 28, 28
Very
what
good.
return
returns. Yes,
in this. Yeah.
very true. So between this two percentages, between this range, that is from 1.43 percentage to 2.63 percentage, we have around 28 entries of returns falling. In the similar manner, we have a number over here as well, that is minus 93 percentage, minus 97 percentage to 0.23 percentage. Around 27 to 28 entries are falling in that range. So what you have observed over here is that majority of the entries are falling in this range, is three ranges. If you see, no, majority of the entries are falling between in these three bars. So numerically, if I say from 0.97 percentage, that is minus, to 2.63 percentage, majority of the returns are falling. Now, what is the exact probability of return which are falling in this range? That we haven't seen yet. But from the chart, I can see that, there are very few chances which are left outside the scope of these three bars where my return would be extremely positive or my returns would be extremely negative. From minus 0.97 percentage to 2.63 percentage, there is a chance that my return would be falling. There is a great chance that my return would be falling. I hope you are able to interpret what I have said to you. Is
Yes,
everyone
sir.
clear? Good. Now, how these returns are generally distributed when we see the normal distribution of the data. If we understand the standard normal distribution, no, this is how the distribution pattern looks like everywhere. In whatever the data you take, no, this is how it behaves. If we find that, it is a normally distributed. Now, if I give you the idea about this normal distribution, say this is a curve. Now, say this is the average. This is the average. And average return is coming at, say, for example, 3 percentage. Right? Try to understand. Just a hypothetical example I'm giving to you. Now, how the other returns are behaving? Try to understand that. Now, after the average, the one standard deviation would take place. No, that is one standard deviation, 1 SD. You add one standard deviation to the average. So here comes another portion and area. Then you add two standard deviations. Here comes again other portion and area. And you add three standard deviations. Again, in the negative side, you add one standard deviation, two standard deviation, and three standard deviation. Now, majority of the returns, around 34 percentage of the returns falls in this area when the data is normally distributed. Around 34 percentage of the returns falls in this area. That means if the standard deviation is, say, coming at 2 percentage, so average plus one standard deviation, so that means what will be the return over here? 5 percentage return. What will be the return at the second standard deviation? That would be 5 plus 2 again, so that would be 7 percentage here. You add 2 percentage again in that, so you get 9 percentage here. Now in the negative side, you will have to reduce the standard deviations from the averages, right? So if you reduce one standard deviation from 3, so that reaches to 1 percentage. If you again reduce 2 percentage from this 1 percentage, then you get minus 1 percentage. And if you reduce again 2 percentage from this 1 percentage, minus 1, so you get minus 3 percentage. So the up to the first standard deviation, 33%, 34 percentage of the probability of return will be falling. So from this I can say that my 68% of the probability is that my return would be there in this area. I hope you are able to get me. Now, approximately the area for this chart, no, that is around 13% of the returns. And this is again 13% of the returns. And the rest of the area would be around 3% of the returns. So in total, we'll be having 100% probability for every returns. So how do you interpret this? The interpretation of the data would be like, within a one standard deviation from average, either in negative side or positive side, you will be having a 68% of the probability of falling of return. Why 68%? 34 plus 34. So 68% of the returns will be falling within a one standard deviation from the average, either at a negative side or in a positive side. Have you got it? Yes or no? Give me a confirmation. Yes, beta.
Yes, sir.
Okay. If you add further 13% plus 13%, 13% of this area and 13% of this area, so that is 26%. So if you add 26% over here in 68, so that reaches to 94%, right? So there is a chance of 94% of your return will be falling between the two standard deviations, either on positive side or in negative side. And this pattern is applicable in every data where there is a normal distribution, right? Now, this entirely depends that, whether your probability of return would be positive or negative. That depends on the average and standard deviation you have. Average and standard deviation. If the standard deviation would be low, say instead of 2%, it would just be 1%, then majority of the returns would be positive. But if standard deviation is high, then there is a equal chance that your returns can be negative too. Say average is 3% and standard deviation is also 3%. That means you might have a very good amount of probability for negative returns too. So that entirely depends on what is the average return you have and what is the standard deviation you have. When the clients generally come to us, not for all the clients, because everyone doesn't understand this, but those people who are too much particular about their risk taking capacity, we generally tell them that, say, if your expectation is 10%, then I generally try to find the standard deviation of those particular assets from the historical data, say that is coming at 5%. Then I calculate that, what is the amount of return coming at 10% in terms of amount. And then I find what is the amount of return comes at 5%. Then accordingly, I give them the range, that in majority of the chances, your portfolio would be varying from this amount to this amount. Now that I can tell because we have done the study behind it. There is a standard deviation study, there is a normal distribution study we have done, and that's why we can say to anyone that, majority of the times your returns will be falling in these ranges. So again, those who couldn't understand this, please focus it over here. This is the average. Around 34% of the probability is that your return would be one standard deviation above or below your average. So in total, there would be 34 plus 34. So that comes at 68% probability that your return will be falling within a one standard deviation of the average. There is a 94% probability that your returns will be falling between two standard deviation of the average. And for rest of the area, there is 6% probability, 3% on negative side and rest 3% on positive side. This is how the standard normal distribution looks like, right? Now, if we try to apply these concepts, then we should first identify that whether the data is normally distributed or not. There are various statistical tests to see the normality of the data. But if we do not do that, if I do not go into very complex tests which are, which needs to be applied to check the normality of the data, we may find it from the kurtosis and the skewness we have for the data. Now, how the skewness and kurtosis are calculated, everyone should be able to focus over here. So if the chart looks like this, no, that means too many returns are falling over here nearby the average. So here 34% probability will not be there. Here there would be a much more probability because too many returns are falling nearby the average. So instead of 68%, there could be a chance that around 75 to 80% of the returns are falling in this area. So that those kind of things, the kurtosis will be very high. But if the data would be like this, then very few return will be falling over here. It would be lesser than 68% because tails are very large, and if the tails are very large, then returns will not be 68% or something. It would be lesser than 68%. In this case, it was higher than 68% of the returns. In this case, it would be lesser than 68% of the case. In both the cases, data is not normally distributed. Here the kurtosis will be negative. Here the kurtosis will be positive. Right? Then the data can be skewed as well, inclined towards the one tail a lot. Like if you see the data like this, say here you have, and this is the distribution you are able to see. So generally you can see that the data is inclined towards this tail, right? And if you find the average over here, somewhere it would be coming. Then data is too much inclined towards this tail. Then again, it is not a normally distributed data. In this case, the skewness will be positive, very high. And data can be something like this as well. On right hand side, there would be some skewed data. This can also be there, right? And if this is the distribution of the data, then it is skewed towards the another side, too much aligned towards another side. Again, the skewness will be negative there. So please try to see those 4 types of charts, and from that, generally we can say from the distribution of the data only that whether the data would be normal or not. If we talk about the finance data over here, थोड़ा सा आइडिया लगा सकते हैं. So kurtosis very positive if the data looks like this. Kurtosis very negative if data is too much spreaded in the shape. I mean the tails are too large, both the tails are too large. Then skewness will be positive if one tail is inclined towards the left hand side, and skewness will be very negative if the tail would be inclined towards this side. But in all these 4 situations, the data is not normally distributed. So if we see the distribution of the data over here, where we have found the distribution of the data, frequency distribution, upside. See, I do not find much skewness over here in this data. But still, for our mathematical understanding, we may find a descriptive statistics that will give us the answers about what is the skewness, what is the kurtosis. And the next question which may come from your side is that, sir, what is the range of kurtosis and skewness within which there is an acceptable data, that this is, we may accept this data for the normal distribution purposes. What is the range of it? There are various research papers written on that, and many of the people have come out with the different ranges. Now, before I go to that range, let's first find the descriptive statistics. From that, I will be able to see what is the skewness, what is the kurtosis, what is the standard deviation, what is the average, what is maximum, what is minimum. All these things would be given to you in one table. Is everyone clear till now? Do I need to explain anything further? I think these concepts you have already gone through, but just for a better understanding, I'm repeating that so you do not get stuck in the finance data right now we have here. सब कोई कंफर्मेशन दे दो.
Clear, sir.
Good. So I have received it from Jinkle. Everyone else? Khyati has said yes. Okay. Good. Now, let's see that what is the kurtosis and skewness coming for that data. There are two functions. One is skew and another one is curt. From that as well, you may find it. And there is another way as well, which gives you the table about the entire descriptive statistics, measure of dispersion से लेके maximum, minimum range, ये सब कुछ का वो अलग से आपको टेबल बना के देगा. So I think that would be a better one. How can we do that? Everyone should be able to see in the data tab one function called data analysis. If you are not able to see the data analysis over there, please let me know. We'll have to do the add-in over here. In case if you are unable to, please let me know. मैं आपको बताऊंगा कि डेटा एनालिसिस टूल कैसे ऐड करना है इसमें. In the chat box, please give me your confirmation, positive or negative, whether it is there or not. If it is not, then I need to explain it to you that how to add that function. Okay. Fudhara, Avni, Vaishali, these students are having it. Anyone else? Everyone, please check it out. If it is not there, then I will let you know. Don't worry. Others, what should I assume, whether it is there or not? Jogeshwari, Anshuk, Dilip, Divya, Janisha, is it there? Mukul, Mr. Onsmi?
Yes, sir.
Okay, so I can see many of the students are able to see there. In case if you are unable to, just explain you how to add that function. You can go to the file tab and from there you may go to the Excel options. From this, click on the options, and in the options you must be able to see the add-ins over here. Click on that, and in add-ins you must be able to see the data analysis tool pack, right? Once data analysis tool pack you see there, then click on it. Yes, hello. Yes, I couldn't get you. Beta, can you just repeat this?
एक्सेल नहीं दिख रहा है सर.
Excel नहीं दिख रहा है मेरा. Is my screen visible?
Yes, sir.
Okay, so from here you may go to the Excel add-in. So please go and you must be able to see options over here in the add-ins. Please tick all and then press OK. And if you press OK in data, you must be able to see in the analyze option data analysis tool 2. Now there is a Excel data version as well, but that is a licensed one where advanced level statistics and mathematical modeling as well you can do. But for us, as per the requirement of the subject, we won't be requiring the Excel data as of now. Some of the concepts like confirmatory analysis and some other tools and hypothesis testing की कुछ बहुत सारी और भी methods है, tests है, वो वहाँ पे आपको अच्छी तरीके से दिखाई देगी. But that wouldn't be required for our data we have here. Okay, so what I'm doing is, everyone please focus here. I'm going to the data tab here, and in the data tab, everyone should be able to see the data analysis. Please click on that. And in data analysis, I do not want anything else. There are various options. Even t-test can be done over here, regression, sampling, various things are there. I'm clicking on the descriptive statistics as of now. Just give me a 1 minute. My charger is. Okay, so everyone should be able to see the descriptive statistics over there. Please click OK on that. And you must be able to see this sort of a box. Now, for which data I want to do this, button के ऊपर click किया. Then I'm selecting from the first one to the last one. These are my monthly returns. I'm selecting the monthly returns. Right? Now I'm pressing enter. Now this returns are grouped by columns or rows. It is there in a columns. By default, you must be able to see it is in a columns. If data would have been like this, no, horizontally given, then you would have selected the rows instead of columns over here. In this case, we want to find it vertically. So column we are selecting. Now where we want this output, you may put your output somewhere in a different worksheet. But in my case, I want to put the output below those returns only. Say here. Here I want to put the output. So I'm clicking on that cell, pressing enter. So what did I do? I clicked on that button. I went to the cell where I want the output to be displayed. Then I again placed enter. Other thing we are not going as of now. We are just clicking on the summary statistics. Please tick over here, summary statistics, this button. Everyone. Is everyone there with me till now? Give me a confirmation, positive, negative.
Yes, sir.
Good. Then press OK. And over here, you must be able to see the mean. This is the mean. Now here, if mean and everything would be in a decimals. Over there, we had taken in the percentages. So please do not get confused. Both are one and same only. So mean is this. Standard error tells you, that if in inferential statistics, when we try to extrapolate our conclusions to the population based on the samples, then my mean would be different, may get different by 0.0015 if I try to extrapolate this to a population. So there is some sort of a calculation behind it, not going into that as of now, but just giving you a simple interpretation of it, that if we try to extrapolate our analysis about the mean to the entire population of the data, then it may vary by this many percentages. That is called the standard error, right? Now then you have the median, then you have a mode, then you have a standard deviation, sample variance. Now here you have kurtosis and skewness. Now we were there into the normal distribution. So just explaining you this as of now. Kurtosis 0.32 means, the tail would be little bit like this, and skewness is also positive, so here it would be little bit inclined. But this is the acceptable range. Now if I refer certain research papers, they say me that if as far as the kurtosis is there, some people have taken it from -2 to +2, and some people have taken it from -3 to +3. So even if I accept -2 to +2, this is the range where the kurtosis will be acceptable. The data can be taken into consideration as a normally distributed data. And the range of skewness, for that as well, there were various researches conducted. Some people said that from -0.8 to 0.8, and some people were like from -1 to +1. If we follow this one as well, then also data looks acceptable as far as normal distribution is concerned. Here you have, for kurtosis, you have from -2 to +2, and for skewness, you have -1 to +1. Now, based on the data that we have taken, kurtosis and skewness looks acceptable, right? Now, this is my minimum, this is my maximum. And the range of, the difference between minimum and maximum, this is the range. So range is this. This is my sum total. This is my count, that is 132. So everyone would be doing a similar type of an exercise. And please let me know what is the kurtosis and skewness you are getting on all these two top portfolios. Everyone would be doing it in the 5 minutes to come. Now, next to this only, you will have to give me the result, right? Here you have for the first portfolio, do it for the second portfolio over here, and do it for the third portfolio next to the amounts of third portfolio. Do it, everyone, and let me know what are the descriptive statistics you are getting for all these three. Okay, is my voice audible now, Vaishali, Avni, Divya? Is my voice
Sir,
audible?
now audible.
Okay, good. Thank you. Okay, so those couldn't listen me, please again try to understand that what I have told you is that we want this sort of a descriptive statistics for all three portfolios. For portfolio number 1, I have done it. How did I do? I was not required to select even the data before I go over there. Selection data and everything was visible over there only. Let me do it for the second portfolio so that you will be able to get it in a better way. Everyone, please concentrate. I'm going to the data tab, and in data, I'm going to the data analysis, selecting the option of descriptive statistics from here, from this dialog box, right? Pressing OK. So this sort of a table, again, dialog box would be visible to me. Now it will ask me that for what data you want to take this descriptive statistics. So I'm clicking on this button. I would give the range of the data. For the first one, I have already done. Now I'm going to the second portfolio, and the monthly return of the second portfolio starts from this, that is 0.75. लेकिन हमारी अधूरी कहानी, यहां तक हमें खत्म नहीं करना है. वी वांट टू गो फॉरवर्ड. हमें डेटा सिलेक्ट करना है अप टू द लास्ट. सो मैंने एंड तक का पूरा डेटा सिलेक्ट कर लिया, and the shortcut key which I had given to all of you, that was shift control down arrow to go to select the data up to the last cell of the active data range at the downside, right? Once the data is selected, press enter. then you may go to, yes, whether the data is grouped by column or rows. We would be by default selecting the column because data is vertically given to us, right? Not horizontally. If the data would have been given horizontally, we would have taken rows over there. Okay. Now labels in a first row, that you will have to click when you have taken the heading as well. And if the heading you haven't taken, no, then there is no need to tick on this. Saying that the heading was what? The selected data. The heading was, I guess, the return, right? The monthly return was a heading. While selecting the data, if you would have selected from the monthly return, then you would have written it. But in this case, it's not selected. Okay. Now it will ask me that where you want output, Mr. Ronak. I would say I need the output somewhere. I'm clicking on that button and I would say that I need the output over here. So I'm selecting that cell. Here I need the output. Just me a minute. Okay, then pressing enter. Then the option of summary statistics must be visible to you. You please click on that. Wherever you want to output, if you want this output to be displayed in some other workbook, you may select that as well. But here in this case, I want this in this workbook and this worksheet only. So I'm selecting only the range. Click on the summary statistics from here. Confidence level and everything we are not taking as of now. Press OK. And you must be able to see the descriptive statistics of the second one over here. Now, what is the kurtosis and skewness you are able to see there? And if the skewness and kurtosis both are near to 0, no, then it tells you, that the data is very perfectly normally distributed. In this case, we have a greater amount of kurtosis, but skewness is very much near to 0. So data is not at all skewed, that we have understood. I mean, not inclined towards left hand side or right hand side, not very much inclined toward left and right hand side. That is one interpretation. But yes, little bit kurtosis we are able to see there. But still, this is within the acceptable range of the data. And in the similar manner, you would be doing for third one as well. Please do it. And once it is done, then please give me a confirmation through the chat box that you have done it. Good. Giving 30 seconds to other students to do it. Everyone, please do it. Okay, once the third would be done, what is the skewness coming for the third one? Can someone tell me? And the kurtosis as well. Whether it is in an acceptable range. Jogeshwari, Avni, whether the skewness of the third one is in an acceptable range or what? Okay, so third one is having a higher kurtosis. And skewness is 0.01. So that means that is not at all skewed, right? Yes, within the acceptable range. So we may assume with the assumption of normal distribution of the data, we may go ahead with that assumption now. Vaishali, are you able to understand whatever I'm saying till now? Any doubt, any question?
Sorry.
Yes.
Okay, good. Mr.
Yes,
Mohammed,
sir.
Mr. Onsmi, everyone is able to get it.
Sir, just can you repeat how to select the data in column?
Okay. So first you are supposed to go to the data tab, and in the data tab, your second step was to go to the data analysis, then go to the descriptive statistics, press OK. Then click on the range for which you want the descriptive statistics. Now the range shall be for the third one. I'm selecting it. Must start from somewhere. Just give me this chart is there, needs to be taken. Now I think it should be visible better. Data analysis, descriptive statistics. Okay. Now input range is the range for the data. Now for the third one, I'm selecting the monthly returns from 1.70 percentage to the last one. Control shift down arrow. Now once that is done, then you may press enter. So this is the data selected.
Okay, sir. Done. Thank you.
Where you want the output, for that as well, you need to give the range. Say I need the output over here in that cell, this cell. So I'm clicking on that, pressing enter, and again pressing enter. And the summary statistics must have been ticked over there, right? Pressing enter. So you have for the third one too. But the data looks little mess because of these pictures. Okay, so kurtosis is coming at 0.75, skewness is 0.01, absolutely not skewed. Yes, we have too many values near to the average in this case, but still within the acceptable range of the kurtosis. Now let's go to the yearly return. Now what has been asked over here, please try to identify, understand that. If one client comes to you and says that, what is the average return I'll be having in the entire year? So based on the historical data, first task for you would be to find the average of the yearly returns for all these three clients. Now this average return which you have seen in past 12 or 13 years, you may at least say them based on the previous experience you had for 12 to 13 years, you may say that, sir, your average return may go around 8.44 percentages if we extrapolate the same historical data in the future. If we expect the similar type of a return in the future, then the return from this portfolio may go to 8.44 percentage on yearly basis. So for that, I have taken the average of the previous all the years. So equal to AVE RAGE, opening the bracket, and the average of all the years we have taken, right? Everyone, please find the average of all the returns there. Closing the bracket, pressing enter. So 8.44 percentage is the average coming. What is the time now? 10.24. Okay. Please find the average return of all these two investors. इसका भी एवरेज निकालो, सेकंड वाले का भी एवरेज निकालो. अब हम स्टैंडर्ड डेविएशन में ऐसा लगेगा तो नेक्स्ट टाइम आते हैं, कोई बात नहीं. Standard deviation and this 68% is the probability. I think you will be able to get it now. After understanding the normal distribution of the data, if you are able to solve this too, no? So that is a homework. If you can do it, please do it. And please try to explain me that how did you find your answer. So that is a one task which I am leaving up to you. But definitely I'm going to tell you in the next lecture as well that how to do that. There is no rocket science involved over there. What is being asked is, that what is the highest expected return in 68% of the probability, and what is the lowest expected return in the 68% of the probability of distribution. Please try to apply the logic of normal distribution data and standard deviation, which I have given to you just a few minutes back over here. This one shall be useful to you. You may take a snap of it. Up to one standard deviation from the average, there is a 34% probability in left hand side as well as on right hand side. Right hand side is for the positive returns. I mean, you will have to add the SDs to the average. From here, you will have to reduce the standard deviations from the average. But I'll explain you, don't worry, in the next lecture. If you can, you should do it. That's it from my side. Please do not leave this. I'm going to share the attendance file with all of you. Meanwhile, if anyone is having any question or queries, please let me know.